and 2.1 that we need to talk about.
Jack Horner, you
All-
just see flipping lights. Great, lights.
Hey,
That was funny.
Never mind.
We tell him to be quiet.
He did shut up.
nice, that's gonna be on here, so just so you know, when you go to Blackboard, you'll be hearing it. All right, the equation, okay, that we're gonna use for vertical free fall motion. Now, it's a distance, and it measures distance, okay? Distance in this case, it's written like that, S of t. Don't know why they use S, they just do. T is typically in seconds, all right? All equations are -1/2 times the gravity of an equation, okay, times t squared minus okay? What this means is this is the V sub 0. Any idea what V might mean in this case? Because we're talking about free fall.
Velocity.
Yeah, it's the velocity. Okay? Right. I'm sorry. These are pluses, though. Okay? Yes. G stands for gravity. Okay? If we are doing English measure, then it is -32 feet per second. Okay? If we're doing metric, it's a -9.8 meters per second. That's called initial velocity. That just means the beginning velocity. So if we did a problem where you were throwing a baseball into the air, the throw would have an initial velocity, or you're shooting something out of a cannon, it would all have an initial velocity. The S sub 0, because S measures distance, the S sub 0 is your initial height. And the ground equals 0, okay? So the only time that you would have something is maybe you might be standing on a platform. Maybe that's 5 feet high, so that would be 5. You could be throwing something off a building of a certain height, and that would be the number right here, okay? But that is the initial height from the ground. This is a quadratic equation because you're squared and you've got this. If you were to enter it into your calculator, all right, you would need to know these things right here. These are going to be numerical values. Those are going to be numbers, all right? And if you put it into your graphing calculator, you would just replace the t's with x's. Do not go into parametric mode just because you see the t. You just put it in the regular function mode, okay? You don't have to worry about anything like that. Let's do an example, okay? Let's say that you've got this tourist, okay? And I don't know, he's dropping something. A tourist drops a rock. Okay, there you go. This guy, he just drops this rock off the guardrail, overlooking this valley.
What if
Okay.
he throws it?
Oh, we're going to get to that. That'll be next. Right now, he's just dropping it. So if he just simply drops it, okay, the initial velocity is 0 because he's not throwing it. There's no force. He's just dropping it. We're going to say, for instance, that if he drops it off the guardrail, how high up is about the guardrail where he drops it?
10 feet.
10 feet? No, remember, he's standing there with the rock in his hand.
Yeah.
Oh, well, no, it's like this. This is the guardrail, okay? Here's the valley. He's just standing here, and he drops the rock. I know, but he's not going to climb up to the top of the guardrail. He's going to put his hand through. So how long is your hand? Maybe 3 feet? Since we're talking about feet, then we're going to do gravity as a negative 32 feet per second. Okay, write an equation. Well, let's see. S of t equals, let's see, 1/2 times 32, so that's going to be a negative 16 t squared plus initial velocity, which is what?
0.
Okay, so this is gone.
It's negative half.
Oh, yeah, so it's like that then. I mean, this has to be negative. So just when you do it. Let's see. Then what else? This middle term is not around because v sub that's 0, but plus how much? 3. So now my question is, how far down is the rock after 4 seconds? What is it? Well, yes, put 4 in for t. So we do S of 4.
I was positive.
Okay. 16 times 16, what do we get there? Isn't that like 2 something? I think it's, what is it?
256.
Thank you, Jenny. So it's a negative 256 plus 3, so it equals a negative 253. Wow. It is 253 feet into the valley.
Wow.
Yeah, that's, I don't know if maybe they're at the Grand Canyon or what.
Not even that bad.
Yeah, that's pretty far.
Oh, good job here.
Okay? And then that's it.
Not
And
that
then,
hard, Mr. C.
no?
Wow.
Seems pretty far.
Wow, yeah, it's really far.
How far down is the Grand Canyon? Does anybody know?
A mile.
Really?
Yeah, I fell off of it probably not.
Okay, Mr. C, if you think a football field is 100 yards, there's 3 feet in a yard.
That's
Oh,
300
okay.
feet.
I guess.
300 feet.
That's not, you're right.
Not even a football field.
Okay. All right. It's dropped. Well, now what if we said, like we said, what if you threw the rock? Okay? What if you decided to give it a little toss? All right? So now let's say that you tossed it.
Oh,
And so now it has an initial velocity of how hard can you throw it maybe? You want to whip it or you just want to toss it?
Well, if you say with it and you're talking to Mason, it's more like a toss.
At any rate, let's say 4
What?
feet per second. Okay?
Math is slow.
That's my initial, okay? So now, how does my equation change? Yep. So now it's just written like this. Negative 16 t squared plus 4t plus 3. And that obviously will make the rock even further down if I did S of 4. What? So then we do that. So then you put 4 in there, and we get negative 256. Oh, but, sorry, the initial velocity is negative, so we have to put a negative in there. Sorry, guys. Because he's throwing it down.
Oh, I got
You learn that. If you take physics, you learn that.
you. Yeah, we did.
Oh, okay, there you go then.
That's why I said I know what you mean.
Alrighty then.
You don't have to worry about it.
So now, when you put it all together, we ended up being negative 269 feet. A little bit further down. Any questions on that? This formula is, right up here, is the one that you want to remember. Okay? All right. The last thing we want to talk about is the average rate of change. Okay? If I have an equation of something, last thing, guys. Let's say f of x equals, bless you, okay? And I want to know the average rate of change from x equals 1 to x equals 3. Okay? Does anybody remember how you find an average rate? We talked about this a little bit the other day. If you're driving, that's a rate, and that's in miles per hour, correct?
Yeah.
Right. So, an average rate is kind of like a slope. And how do you find the slope of something? Change in what over the change in the what? Rise over run. And the rise relates to the x's or the y's.
Why?
Okay, this is kind of like a slope, you guys. And so it's like y2 minus y1 over x2 minus x1. So, f of x is the same as y2. That's my second point. So it is f of 3 minus f of 1 over 3 minus 1. Okay? So now what you do is you just need to put 3 into the equation. Does that make sense? F of 3 is going to equal 3 squared plus 4 times 3 minus 10. Minus, and then I put 1 in the equation. And then 3 minus 1 is 2. All right, so not too bad. 9 plus 12. 9 plus 12
21.
minus 10.
11.
Okay. 5 minus 10 is a negative 5. So we end up with what? That's really 11 plus 5. 16 over 2. 8. And it's 8 what? Well, whatever we had here. It could be feet per second, meters, miles per hour. You know, that modeled something. Yes. Here, right up here. What would you rather write? Like just y? What?
3 minus
Right here.
Oh, wait, what's that?
That's the x2 minus x1. x2 minus x1. Okay? All right. Homework. I'll get it.